So in this question, we're given a geometric sequence in algebraic format. The first three terms are 4x and x plus 3. Now from that information, we want to try and find the eighth term and find x. So as that's term 1, term 2, term 3, if I just write them out, I've got 4, I've got x and x plus 3. What I know is, as it's a geometric sequence, these have a common ratio. So the ratio from here and the ratio to here is going to be the same. So how do we find what the ratio is? Well, if you check the previous video, you'll see that when we divide the following term from the previous term, that gives us our ratio. So the ratio here is x over 4. And then the ratio here will be x plus 3 over x. So that's our ratio. Now we know it has a common ratio. So then these two are actually equal. So if we know they are equal, then we can solve for x from that position there. So let's do that. So I've got 4 in my denominator here and x in my denominator here. So let's multiply everything by 4x. So times everything by 4x. So times this side by 4x, the 4 will cancel out and I'll have x times x, which gives me x squared. Break this apart, x over x, what am I going to get with the x plus 3? So 4x divided by x will just leave me with the 4, but times this x, I'll be left with 4x. And then the 4x times the 3 over x, the x's will cancel out and I'll have to multiply the 3 by the 4. So that will give me plus 12. Okay, so we're nearly into quadratic format, which is what we should always try and do if we get this opportunity, because they are pretty straightforward to solve. So let's subtract 4x plus 12 from both sides. So now I've got x squared minus 4x minus 12. Then this side I'm left with 0. And now we can solve that as a quadratic. Okay, so now we can factor this out. So factors of minus 12. So let's see what we can do with that. So while I'm thinking of my factors, let's write out my setup. Now minus 12, I need a difference of minus 4. So 6 and 2 spring to mind straight away. So let's put my 6 and 2 in there, and then let's decide on what signs I need. Well, I need a minus sign for my value here. So these two need to multiply and get a negative. So they must have a different sign. And my sum is minus 4. So therefore my biggest should be on the minus. So if that one's minus, then this one should be the plus. So therefore I can say x equals 6 or x equals minus 2. So that's my two solutions for my values. So x equals 6 or x equals minus 2. Let's just plug them in to our geometric sequence and see if they work. So I've got 4. So for x equals 6, I've got 4, x equals 6, and here I've got 6 plus 3, which is 9. Okay, now is that a geometric sequence? Well, remember, look what we did here. We divided the following term from the previous. So now I've got from here to here, I've got 6 over 4, which equals 3 over 2. And then from here to here, I've got 9 over 6, which also equals 3 over 2. So yeah, x equals 6 is checked. That's definitely a valid result. What about x equals minus 2? So x equals minus 2. Let's check that one. So now I've got 4, x is minus 2, and then minus 2 plus 3 gives me plus 1. Right, let's see if that works. So now minus 2 divided by 4 gives me minus 1/2. And then here I've got 1 divided by minus 2, which also gives me minus 1/2. So they're both valid results for my x terms. So I can write up here now x equals minus 1/2 and x equals 3 over 2. So that's my two solutions for x. Now we want to find the 8th term. So now we've got two geometric series to find the solutions for with our common ratios. There's two different common ratios. So let's do that. Let's clear the board and let's do that. Okay, right. Let's try and solve now for our 8th term using x equals 6 and r equals 3 over 2. So let's go with that one. Now, geometric sequence has the formula a times r to the n minus 1. So a is the first term. Let's write these over here. A equals first term. R is the common ratio, which we've just done. We've got the two common ratios to deal with. And n is just the number in the sequence, or nth term. That's what we're trying to use the n for. Okay, right. So now let's plug those values into here that we have and see where it takes us. So using this one here, x equals 6 and r equals 3 over 2. Let's deal with this one first. So first term is 4. So therefore u of n, let's find the nth term first. We'll get the 8th one after. So it equals 4 times 3 over 2 to the power of n minus 1. And that would be fine, but we can simplify that because 4 is to the power of 2. We can write that as 2 squared. So then we would get 2 squared times 3 to the n minus 1 divided by, I've got 2 to the n minus 1. Okay, let's simplify this off because I've got 2 squared and 2 to the n minus 1 and they're multiplied, so I can combine these. So therefore my nth term will be 3 to the n minus 1, and then in my denominator I've got 2. Now I've got 2 squared in the numerator, so if I reduce this by 2, that will take care of that. So now I've got 2 to the n minus 3. So that would give me my nth term formula. Now what about if I want the 8th term? So u of 8 gives me 3 to the power of 8 minus 1, which is 7. And then I've got 2 to the n minus 3. So 8 minus 3 is 5. That's 2 to the power of 5. So that's going to give me 3 to the power of 7 is 2,187. And then 2 to the power of 5, that's 32. So we could leave that. That's a genuine enough answer. But we can simplify that to 68 and 11 over 32. I'm going to leave that for you guys to check that answer. But that's what I'm going to give for my 8th term for when x equals 6. Now, let's have a look at what happens when x equals minus 2. So my ratio then is minus 1/2. So this is going to give me a shrinking alternating series because my ratio value here is got a modulus value of less than 1. So let's see what happens now. So I'm going to make a new formula. So un equals a times r to the n minus 1. So we can't reuse the one we did here because here the ratio is 3 over 2. So we've got to just change it a little bit. So then that equals, first term is 4 times the ratio, which is minus 1/2 to the n minus 1. So as we did before with the 4, we can write that as 2 squared. So then that equals 2 squared times minus 1 over 2 to the n minus 1. Now we can break this fraction apart and get the alternating series out the front. So the minus 1 to the n minus 1, I'm going to leave at the front. So it's minus 1 to the n minus 1. So that's nice notation there to know it's an alternating series. And then we've got 2 squared divided by 2 to the n minus 1. Well, as we did here, that's going to yield the same result. So that's going to give us 2 to the n minus 3. So then we're going to multiply this by 1 over 2 to the n minus 3. Okay, right. Now let's find our 8th term from there. So u of 8 gives us minus 1 to the power of n minus 1, which is the power of 7. So So that's going to give us a negative value. It's going to give us -1. And then times that by 1 over 2 to the power of n minus 3. Well, n is going to be 8, so that's 2 to the power of 5. So that's going to give us -1 over 32. And that will give us our result for our sequence here when x equals -2 and the ratio equals -1/2. So that's our two answers for our 8th terms. Okay.